we are recording. So with that being said, let's go ahead and start this lesson. Today we're going to talk about metric conversion. So before we talk about that, I'm going to show you guys a quick video to make sure we understand it.
What does the French Revolution have to do with the time NASA accidentally crashed a $200 million orbiter into the surface of Mars? Actually, everything. That crash happened due to an error in converting between two measurement systems, US customary units and their SI or metric equivalents. So what's the connection to the French Revolution? Let's explain. For the majority of recorded human history, units like the weight of a grain or the length of a hand weren't exact and varied from place to place. And different regions didn't just use varying measurements, they had completely different number systems as well. By the late Middle Ages, the Hindu-Arabic decimal system mostly replaced Roman numerals and fractions in Europe. But efforts by scholars like John Wilkins to promote standard decimal-based measures were less successful. With 250,000 different units in France alone, any widespread change would require massive disruption. And in 1789, that disruption came. The leaders of the French Revolution didn't just overthrow the monarchy. They sought to completely transform society according to the rational principles of the Enlightenment. When the new government took power, the Academy of Sciences convened to reform the system of measurements. Old standards based on arbitrary authority or local traditions were replaced with mathematical and natural relationships. For example, the meter, from the Greek word for measure, was defined as 1/10,000,000th between the equator and North Pole. And the new metric system was, in the words of the Marquis de Condorcet, for all people, for all time. Standardizing measurements had political advantages for the revolutionaries as well. Nobles could no longer manipulate local units to extract more rent from commoners, while the government could collect taxes more efficiently. And switching to a new republican calendar with 10-day weeks reduced church power by eliminating Sundays. Adoption of this new system wasn't easy. In fact, it was a bit of a mess. At first, people used new units alongside old ones, and the republican calendar was eventually abandoned. When Napoleon Bonaparte took power, he allowed small businesses to use traditional measurements, redefined in metric terms. But the metric system remained standard for formal use, and it spread across the continent along with France's borders. While Napoleon's empire lasted 8 years, its legacy endured far longer. Some European countries reverted to old measurements upon independence. Others realized the value of standardization in an age of international trade. After Portugal and the Netherlands switched to metric voluntarily, other nations followed, with colonial empires spreading the system around the world. As France's main rival, Britain had resisted revolutionary ideas and retained its traditional units. But over the next 2 centuries, the British Empire slowly transitioned, first approving the metric system as an optional alternative before gradually making it official. However, this switch came too late for 13 former colonies that had already gained independence. The United States of America stuck with the English units of its colonial past, and today remains one of only 3 countries which haven't fully embraced the metric system. Despite constant initiatives for metrication, many Americans consider units like feet and pounds more intuitive. And ironically, some regard the once revolutionary metric system as a symbol of global conformity. Nevertheless, the metric system is almost universally used in science and medicine, and it continues to evolve according to its original principles.
All right, so with that being said, a cool example, if you've ever been out of the country, the easiest example I can give you is temperature. For example, the first time I left the country, I wanted to check the weather so I could make sure my fit was appropriate. And the weather was given to me in Celsius. And I'm like, is that hot or cold, right? Luckily, smartphones, look it up on Google real quick and do the quick transition. But the same thing happens every time you leave the country. Like when you're driving a car, instead of miles per hour, it's kilometers, right? Because different countries, literally, there's only 3, including us, that don't use the metric system. And pretty much everywhere else, they use the metric system. So for us, since they mentioned in the video, science uses the metric system, we do too, as far as chemistry. So we have to make sure we know how to use it. So since it's French, the actual name for it is there. I don't speak French, so I don't want to make that pronunciation even more terrible than I probably. So we're just going to say SI system, or we call it the metric system. And remember, this is where your notes come in your notebook. So there's only 2 things you need to know. It's known as the metric system, aka the SI system, and it consists of a base unit and prefixes. And it's not new to us. We've seen it. Like Americans here in America, we sneak in pieces of the metric system. We just don't use the system as a whole when it comes to measurements. But you've seen some of them before. So as far as your notes, you have this table here, but you just don't have the values. So this just shows you the different values that come with the different prefixes as far as the metric system. And some of these prefixes you've seen, or at least I know you've heard, especially if you watch some sort of cop show, you've heard these prefixes before. For example, kilo. Kilo, especially for those of us that watch crime shows, that's usually how they describe a brick of cocaine, right? But that literally means 1,000 grams. So that's why it's so big. You have 1,000 grams. But instead of saying I have 1,000-gram brick, they just say I have a kilogram, or they even make it very short and they just say I have a kilo. So that's definitely one you've heard before. Then there's hecta, deca. Now base. Base means there's no prefix. So you can see that a couple of times. So here we have G stands for grams. L stands for liters, meters, and seconds. So that's just the unit without a prefix because it equals 1. So the different prefixes actually tell us, if you look at the values, different values of 10. So this is like 10 to the first, 10 to the second, and 10 to the third because there's 3 zeros. Versus then you have prefixes for smaller things. So here we have deci, and this is one we've all seen, which is crazy, on our ruler. Even on our regular American or United States ruler, where we measure in inches, you also see the little marks, and those little marks are centimeters. So now we'll see how we've seen this already. So centi is the prefix that stands for 10 to, in this case, the -2. And then meters is the base. So versus if you've seen an actual meter stick, right? A meter stick is pretty big because a meter is definitely way larger than a small centimeter. So it's a way to describe the same number, but in different ways using prefixes. So it's a way to make it easier. So you have 2 different spaces on your table because there's 2 mnemonic devices that help you memorize these. So the first one is King Henry died by drinking chocolate milk. And it's important to have a mnemonic device because you have to know them in order. That way, when we convert between the different prefixes, it'll be easier because you know them in order. So that's the cute, corny one. There's also one that's a little bit ratchet. That's the one I prefer, which is kings have diamonds, but diamonds cost money, right? So pick whichever one speaks to you, as always, but just remember, we're going big to small. So kilo in this case, and there are other prefixes, but kilo is just as far as we get together. Kilo is the larger one. So you have a big number, and then all the way down to milli, which is interesting. So when we think of milli, we think big, but it's actually really small, 10 to the -3. And milli, something we've seen even in the centimeter rulers, the millimeters. So this shows you that a millimeter is even smaller than a centimeter. So we have these down. Now we need to make sure we know how to use them. So let's just go ahead and get into that. So I'm going to show you something called the ladder method. And what the ladder method is pretty much a way to help you learn how to convert between the different prefixes. So the easier way to do this is to, first of all, make sure in your notes as we're following along that you have these 1, 2, 3. So you have the 1, 2, 3. So make sure you add these words after it. So the first thing you need to do when you're converting is to determine your starting point. So in this case, our starting point when we read this problem is 4 km. So since there's 2 letters, I know the first letter is going to be my prefix, and that first prefix is kilo, so this is my starting point. So my second thing is to count the number of jumps to my ending point, but I need to figure out where I'm ending. Now, when we read this problem, they want us to change from kilometers to just plain meters. So someone feel free to unmute. Meters, where is meters? Where would meters fall on this? Where would I find meters?
Basic unit.
Right, basic unit. And I know it's a basic unit because it doesn't have a prefix in front of it. It's just simply meters. So with that being said, I know my ending point is base, right here, meters. So that now I can count my jumps. So I'm going to jump 1, 2, 3 times to the right. So 3 times to the right. So now that tells me I need to move my decimal, the same number, and the same, please box that in, the same direction too. So this number isn't written with a decimal though. So when I write 4, can I write 4, do I put my decimal in front as 0.4? Or do I write my decimal in the back as 4 point? Which option should I choose?
Back.
Right, back, right? So that seems like redundant, but you'd be surprised how many people, if there's no decimal, they always put in the front. 0.4 is not an estimate, okay, of 4. Remember, because another way we can write 4 is 4.0. So remember, but there's not a decimal written, just write it right after the last number. And now we're going to do what we just saw. We're going to move our decimal 3 times to the right. So that's 1 time, 2 times, 3 times. So this is a new place for my decimal. And then what do you suggest I put in the open spaces?
Zeros.
Exactly. We're going to put zeros in those open spaces. So that means 4 kilometers or kilometers is actually 4,000 meters. Then that's another way to double check that, because if you remember, meters is the base unit, and then kilo stands for 1,000. So that means it's going to be 1,000 times bigger than our base unit. So that's how we end up getting 4,000. Is there any questions with that example, or are you guys feel safe enough to go to the next one? All right, I didn't hear any questions or concerns. So we're going to go ahead and go to the next one. All right, so you guys didn't have a number, right? I didn't give you guys the ladder because I don't want you to get used to it. I'm going to show you how I normally do this, even like when I do my Aaron keys. So I just write the first letters of each of them. So kings have diamonds, and Deca is the only one that has 2 letters. It's DA. But, right, I like to write base bigger. Diamonds cost money. I just think of this as my line, so that way when I'm doing a problem, all I have to do is figure out where I'm starting and where I'm ending. Okay, so that's easier for me. Which one? Okay, which one does M stand for? I know there's M here, but someone remind me, M, what's the prefix?
Millie.
Right, milli, so it means I'm starting at milli, thank you. And then I'm ending up at plain G, and plain G is what?
Grams.
Right,
Base.
grams or just base, right? So I'm starting at milli, then I'm gonna jump 1, 2, 3 times. Now, the one thing you don't do, and I've seen students do this just because it's new, is jump in between and add different jumps. Don't do that, okay? So just jump from one to the other, one to the other, one to the other, so you don't accidentally mess up your jump. So I know that's 3 jumps to the left. So when I look at my number, 1,000, it wasn't written with a decimal, but remember, we just learned that it always comes after the last number when it's not written. So now I know I'm starting here, and I would move it 3 places to the left, just like I moved my jumps. So I'm gonna go 1, 2, 3. So I can include all of these zeros, or I can just literally write my final answer as 1 gram. You can include them or not, but it's the same thing. Hey, does anybody need me to do another example, or did you want to try the rest on your own? Okay, so I'm going to take the silence for independent work time. So I'm going to set my timer for 5 minutes, and I'm going to give you guys 5 minutes to go ahead and try the rest of those examples. And remember, these are in your digital notebook. I'll give us some music, and then we'll be back to discuss the answers. Oh, but okay, just about 2 minutes left. Remember, if you're finishing, feel free to throw a plus in the chat so I'm not waiting for everyone and everyone's done already. See, we have some early finishers. For everyone else, we're just at our last minute. So don't rush yourself. Take your time to get through how many you can. And you're going to have more time to practice. More attempts to practice later on your homework. about 5 minutes. Let's just go ahead and go through these examples. So I'm just gonna post the answers. And then if you have a question about one, just let me know. So for the second question,
Come down.
for the second
Okay, good.
question, it's 1,000, 1,600,
But aren't you gonna be hot?
14,000, 0.109, oopsie, 0.250, and then 56 centimeters is less than 6 meters, and 7 grams is actually much larger than 698 grams. All right, so does anybody have any questions about any of those before we continue? Okay, so I'm going to take the silence as a no. And we're going to go ahead and continue. So when we look at our reference table, we'll see that table C is the first page in your reference table. And I got a lot of emails about this when you guys did the homework from Friday. The reference table is posted on the Google Classroom under resources. You know, if we were in person, I would have given you one, but you know, this is what it is. So it helps to have it bookmarked because you're going to need it to answer some problems. So I gave you the mnemonic devices because it's easier to remember it that way. Because as you're looking at the reference table, you'll notice that it's missing some, like between kilo and deci, it's missing not only hecto and deca, but it's also missing base. Then after milli, there's actually 3 more prefixes that you'll see, micro, nano, and pico, and those are even smaller. So in your notes, you'll see that you don't have the 2 or the 3, so just make sure you have those with you. And you will see problems that might ask you to convert past milli and go to micro and nano, so I want to just make sure you guys know how to do that. Remember, since the metric system is based on powers of 10, I say when you go from milli to micro, since you go from 10 to -3 to -6, that's actually there's 3 jumps. Same thing between micro and nano, that's 3 jumps, and between nano and pico, that's 3 jumps. Let's go ahead and try this first problem. So right now we're going from grams. In grams, now I'm just gonna stop using my entire line because I don't need it. Grams is my base unit. Then they want me to end up at nanograms. So let me show you how to set this up. So first we're gonna use what we know. Kings have diamonds, but deci, diamonds, cost, centi, money, milli. Now that we got to milli, we need to keep going because we want to get to nano. So after milli comes micro, and remember that's 3 steps. So I'm just going to enter an X for 1 step, an X for another step, and then I'm going to go ahead and enter the symbol for micro. That's cute, right? But remember, I want to get down to nano, so I need to go down again. So I need to go down 3 more. So I want to do 1 step, 2 step, and then I'm going to enter my N for micro. So now that I have all of my steps written out, it's going to make it very much so easier for me to go ahead and record my jumps. So starting from base, I have to move my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 whole times to the right. So if we look at my original number of 1.8, I have to move that decimal 9 times. So here's 1, then 8 more times, 2, 3, 4, 5, 6, 7, 8. And what do I put in all these empty spaces? Right. Exactly, we put 0. So let's just go ahead and throw those zeros in. 2, 3, 4, 5, 6, 7 zeros. So we can rewrite it 1, 8. Then we counted 1, 2, 3, 4, 5, 6, 7. Oh, 8. You guys didn't catch me. I didn't do enough jumps. 9. 1 more 0. There we go. Because there's supposed to be 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Can you put this in scientific notation? Most definitely. But if not, just showing us how big that number is. That's actually 1.8 billion nanograms. So that's a super big number, but it makes sense because nano is super, super small. Let's go ahead and try another one. This time, they want to know how many picometers are in this many millimeters. So this time I'm starting off at millimeters.
Miss Walls, I have a question.
What's up?
Can you explain why you put the X's? Again, I understand why, but I'm confused on why it's only 2 and 3.
Because remember the difference between, so if we start here between milli and micro, those are 3 powers of 10. So since there's no unit that comes in between milli and micro, I just put X's just to stand for the different places. So that's 1 place, 2 place, and the 3rd place actually has a name, and that 3rd place is micro. That's why even after micro, once you go from micro to nano, you're going from 10 to the -6 to 10 to the -9. So that's 3 decimal places. So the X's just stand for the different values that don't have units. So 1 place, 2 place, and then that way we got to our nano. So it's just a way to help you mark how many jumps you have to go, because there's no letters that come in between there.
Okay, thank you.
You're welcome. Okay, so for this one, how many picometers are equal to this many millimeters? So this time we're starting from millimeters. So I'm going to put my milli, and we want to go all the way to pico. So once again, Sharon, same thing we did. So after milli comes micro. So that means there's 2 places. 1, 2, then we have micro. Then we need to get to nano, which is another 3 places. So X, X, then we have nano. But we're still not done because we want to end up at pico, so we have to come down one more time. So X, X, and then we end up getting our pico. Now that we have all of our letters, we can go ahead and do our jumps. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. A whole lot of jumps. But this time we're going 9 places to the right. So our original number was 0.359. We're going from millimeters, right? And now we're trying to get to picometers. So we're going to the right, so our number should actually get bigger. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I know this can be a little bit confusing, but we're starting off with milli and we're going to pico. So with that being said, remember in the spaces, we're going to put some zeros. So that's 1, 2, 3, 4, 5, 6 zeros. So the number actually becomes 359 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. And if you want to put your commas, so that's 359,000 picometers. And that's our unit PM. Almost similar to time, but it's different. So these are like the most difficult ones you'll see, only because we have X's this time because we don't have values assigned to those numbers in between. But otherwise, the kings have diamonds, but diamonds cost money is what you'll see most often. You don't really see these mentioned a lot, but you have to at least be aware of it just in case you do have a problem that involves it. So in general, when you're doing these problems, definitely remember the prefixes in order. And then remember, if it's a letter by itself, that's considered base. And always move the decimal in the same direction as your jumps. That's the most important part. And if the numbers alone, remember that the decimal comes at the end of it and not the beginning. But with that being said, I'm going to show you guys it's a quick video. It's a clip from The Simpsons. And my question to you is, what mistake did Mr. Burns make? If you've never watched The Simpsons before, Mr. Burns is the boss man. So what mistake does he make?
Before we adjourn, gentlemen, I have one last matter of utmost importance. I need to send this parcel with the profit projections to Pete Porter in Pasadena. And it absolutely, positively has to be there overnight.
That's Mr. Burns.
Pete Porter, pass it on.
Pasadena, promptly.
Package parcel processing pronto.
Forgot Prendergast, profoundly pressing package of power plant profit projections for Pete Porter in Pasadena.
Priority.
Precisely.
Here's your package, Mr. Burns. My name is the return address, you senseless dunderpate. Smithers, who is this nincompoop?
I've worked here for 10 years and my boss doesn't even know my name. Well, that's gonna change right now. My name is Homer J. Sip. Ow!
Sounded large when I ordered it. I can't make hide nor hair of these metric booby traps.
All right, so what mistake did Mr. Burns make? Because clearly he intended to hurt Homer.
The weight wasn't heavy enough because it was only 1,000 grams.
Right, it was only 1,000 grams. So I can't restart the video, but I'll just show it to you. So remember, if you looked at the anvil, it said 1,000 grams. So he saw 1,000 and was like, oh yeah, that's definitely heavy, but it's actually really not. Now, what's a value with 1,000 that probably would have done what he wanted to and smashed Homer? So instead of 1,000 grams, which is something he probably should have ordered?
Kilo.
Right, 1,000 kilograms would have been much more heavier. And you know, with cartoons, when they do something like that, it usually smashes them. So if he wanted to smash Homer, that's probably what he should have done. And thank you guys for participating in that. And that was just our way of connecting what we've learned to something actual. Well, in this case, it's not real life. It's cartoon, but you get it. So up to this point,